Systems of linear equations. This is a digital lesson, and it covers graphing, elimination, and substitution. So you might want to take 2 or 3 days on this slide deck and just allow students to learn each of the different methods and give them a chance to practice. So the lesson starts with explaining what a system of equations is. So it's a set of 2 or more equations with the same variables, graphed on the same coordinate plane. So if we graph these 2 lines, we can see that the solution would be the point where the 2 lines cross. Now there are 3 possible solutions to a system of linear equations. There could be one solution, no solution, or an infinite number of solutions. We're going to show what that looks like to the students. So if we have 2 different lines and they cross at one point, that's one solution. If the 2 lines are parallel, they will never cross, and so there will not be a solution, so no solution. And if it's the same line and they overlap, there will be an infinite number of solutions. So one solution if the 2 graphed lines have one point in common. No solution if the lines are parallel. And if the lines overlap, they will intersect everywhere along the line, which gives them an infinite number of solutions. So on the next 3 slides, students are just going to be typing in either one solution, no solution, or infinite solutions. So on the first one, the lines are parallel, so they're going to type in no solution. The next one, they can see there's one solution. And on the next 2 slides, they're not going to see the graph, they're just going to see the equation. So here we can see that these are 2 different lines, so there will be one solution where they cross. Same thing here. And here we have 2 different lines, but they have the same slope. We know they're different because they both cross the y-axis at different points. But if the slope is the same, that means the lines are going to be parallel, so no solution. And here's an example when the lines are the same, they're going to interact everywhere along the line, and so that would be infinite solutions. Now students are going to be graphing on the next 3 slides. We have movable points and movable lines. So they're given 2 equations and they want to graph them on the coordinate plane and then find the point where the 2 lines intersect. So on this first line, we can see that the y-intercept is -1. So I know there's going to be a point on the graph at -1 on the y-axis. So to move these points, you just click and hold, and then they can move this into place. Now I have 1 point on this line. To find another point on the line, I'm going to use the slope of 2. So from this point, I'm going to count up 2 to the right 1. And when I have 2 points, then I can show my line. So this is a movable line. Just click and hold on it. There are going to be 2 little blue circles on each end. If I click and hold on those blue circles, then I can move these. And I want to make sure I'm showing a slope of 2 all along the line. Now the second line has a y-intercept of 4, so I'm going to move this point to 4 on the y-axis. And again, just click and hold on it. To find another point on that line, I'm going to use the slope of -3. So from here, I'm going to count down 1, 2, 3 to the right 1. There's already a point there. So if I connect these 2 points, I'll have my second line. And again, click and hold. And I'm going to click and hold on the little blue circle and then have this line go through the 2 points. And I want to make sure I've got my slope of -3. Now I have my 2 lines, and you can let students have some time to practice with this till they get the hang of it. But the point where the 2 lines cross is my solution, which would be the coordinates 1, 1. They're going to do the same thing on the next 2 slides. They've got 2 new equations, movable points and movable lines, and then they type in the solution. Now once they've finished graphing, then we're going to teach them how to solve a system of linear equations by elimination. So we want to eliminate one of the variables so we can solve for the other variable. So here I have two equations. If I add these vertically, then it will eliminate the y variable. X plus x gives me 2x. 3y plus negative 3y just gives me 0, so these eliminate. And then 16 plus negative 8 gives me 8. Now I have a one-step equation. I can solve for x. Once I know what x equals, I can put this 4 in place of x in either equation and solve for y. Now I have the two coordinates for 4 as the point where the two lines cross. There's another example on slide 16. Again, I'm going to add vertically. I get 2x plus 0 equals 20. I don't need to write the 0. So it's 2x equals 20. I solve for x, put 10 in place of x in either equation, and solve for y. That gives me the coordinates 10, 5. And you want to remind the students that the x-coordinate always goes first, y-coordinate second. So it's the point 10, 5, not 5, 10. Now students are going to be doing this on the next couple of slides. They're just going to be adding vertically. So here they get 2x plus 0 equals 20. They don't need to write the 0, so it's just 2x equals 20, x equals 10. This is similar to the one we just went over. So here if we put 10 in place of x, we get 10 plus y equals 14. Y is going to equal 4. So I get the solution of 10, 4. Now you notice that there is a letter in a green heart. They're going to use this letter, they're going to match the letter to the solution in order to solve a riddle. They're going to do the same thing on the next slide. We're going to add the two equations together, solve for the variables. Same thing here. Now sometimes we can't just add them together and one of the variables will eliminate, but we could also subtract. So with these two equations, if I subtract the second line from the first line, I get 2x subtract 2x, which gives me 0, 3y subtract y, and 16 subtract 12. Now I have a one-step equation. I can solve for y. I'm going to put 2 in place of y in one of the equations and solve for x. So students are going to be doing that on the next couple of slides. They're going to be solving using subtraction. Now they may be given two equations where they can't add or subtract in order to eliminate a variable, but they could multiply one of the equations by a factor and create a situation where they can eliminate a variable. So here, for example, if we take the second equation and we multiply each term by 2, I get 4x negative 6y equals 6. Now I can take the two equations, add them together, and I can solve for the variables. So students have to think about what they could multiply one of the equations by in order to eliminate a variable. So on the next slide, they're just going to be determining what they could multiply the second equation by in order to eliminate a variable. So their answers could be different here. If I multiply by 2, then I could subtract the two equations because I'd get 2x here, negative 4y equals 2, and I could subtract. If I multiply by negative 2, then I could just add the two equations together because I'd have a negative 2x here. So they're going to have different answers. So you want them just to think about, we're not solving anything here, just think about what they could multiply that second equation by. Now when they get to slide 25, again, they're going to choose a number that they could multiply by the second equation in order to eliminate. So we could eliminate the x variable. So they could choose 5 or they could choose negative 5. So let's say they choose 5. They're going to multiply the entire second equation by 5. Here they're going to distribute that 5, so they're multiplying by x and by 3y. That's going to give them 5x plus 15y equals 55. So we're multiplying 5 all along the second equation. Now the 5x's, if I subtract, they eliminate, and I get 2y subtract 15y gives me negative 13y. It's a little bit tricky. And if I take 16 subtract 55, I get negative 39. And solve. So we want this to be a y. We've eliminated our x, so now we're at y. So y is going to equal 3. Once we know y equals 3, we can substitute 3 for y in one of the equations. And they're going to finish, let's see. Yeah. So they could have negative 5 here, and this would still work out. They would still get an answer of 3. They're going to do the same thing on the next slide. What can they multiply that second equation by in order to eliminate that x variable? And when we get to slide 27, now they've got all of these solutions. They're going to look back at previous slides. When they find these solutions, they're going to type in the letter that was in the green heart. If they've done all of these correctly, they will solve the riddle. Now, once they get through this, we're going to look at another challenge problem here. Now, this is an example of when we need to actually change both equations in order to eliminate a variable. In this case, it's asking them to eliminate the y variable. Now, it really doesn't matter which one we eliminate, but in this case, we're asking them to eliminate y. So I could multiply that first equation by 5. That would give me negative 10y here. And I could multiply the second equation by 2, and that would give me a positive 10y here. So students are just going to be looking to see what they could multiply in order to eliminate the y variable. Now I could multiply this by negative 5 and this one by negative 2. Still going to end up with the same solution. So here, if we choose 5 and 2, I'm going to multiply every term in that first equation by 5 and every term in the second equation by 2. So here I'm distributing the 2. So I'm going to end up with 25x for the first equation, negative 10y equals 15. I didn't need to type that x, so there we go. Now the second equation I'm multiplying by 2, so I get 4x plus 10y equals 14. Now I can add them together, and I get 29x. These two eliminate, equals 29. And I'm going to finish this equation on the next slide. So 29x equals 29. And I'm just going to repeat that here. Now I can solve for x by dividing both sides by 29, and I get x equals 1. Now if I put 1 in place of x, I'm multiplying these two, so I get 2 plus 5y equals 7. If I subtract 2 from both sides, I'm going to get 5y equals 5 and y equals 1. So now I know that the x coordinate is 1 and the y coordinate is 1. And I have my solution. So this one's a little bit tricky. It'll be for your challenge students. Now we go into substitution. We're going to solve for one variable, substitute the solution for the variable in the second equation. So this is how this works. Now here I've got two equations. I want to solve for one of the variables. Now this one looks like it would be the easiest because it's a positive x. If I solve for y, well, this is a negative y, so it's not going to be so simple. So I can solve for x by subtracting 4y from both sides of the equation. That gives me x equals 12 negative 4y. Now 12 negative 4y, I'm going to put in place of x in the other equation. I'm going to distribute that 2. That gives me 24 negative 8y, negative y equals 6. I'm going to combine like terms. I get 24 negative 9y equals 6. Subtract 24 from both sides. I get negative 9y equals negative 18 and y equals 2. So this is substitution. And once they know what y equals, they can replace their y with 2 in either equation and solve for x. They're going to do this starting on slide 33. We want to solve for x. So here I'm going to add y to both sides of the equation. So my x is all alone. And I get x equals y plus 1. Again, y plus 1. I'm going to distribute my 5, so I get 5y plus 5 equals 45. And actually, I've got a 3y here. I need to add that. So 5y plus 5 plus 3y equals 45. I'm going to combine like terms, so I get 8y plus 5 equals 45. Subtract 5 from both sides. 8y equals 40. And if I solve for y, I get y equals 5. Now I'm going to go to the next slide. I have y equals 5. Now I'm going to substitute in, was it the second equation? I think, no, it was the first equation. So I'm going to substitute 5 for y in the second equation. I get x minus 5 equals 1. If I add 5 to both sides, I get x equals 6. Now I have my two coordinates, 6, 5. So they're going to be practicing that on the next slide also. They're going to solve for x, substitute what x equals in the second equation, go ahead and solve for y. So you can see here we've also got, now we've got a letter and a yellow heart. They're going to use that to solve another riddle. Same thing here, they get a little bit more practice. Now when they get to slide 39, they have these 3 solutions. They're going to look back on the previous slides. They're going to type in the letter in the yellow heart, and they're going to solve this riddle. So that is a long lesson. I would take 2 or 3 days on systems of equations.